everyone, welcome back to 2-Bit Circuits Foundation. My name is Evelyn and today we're going to be working on a project called Shybot. So as you recall from last week, we were working on a project called Artbot, which was simply making a wacky marker designer that uses markers as legs. So today we're going to be continuing with that robotics theme this Thursday, with the creation of Shybot. So just a list of materials that you'll require for this project are displayed here on this display here. So what you need is a paper plate, just something basic like this, not too heavy. You'll need 2 wires, red and black, not required to color coordinate, but just 2 wires. You can also use paper clips or zip ties. You also have an offset motor. We have a small breadboard. We have a battery pack with 2 wires as well. And we have 2 AAA batteries. We have 1 transistor right here. We have also a photocell. And lastly, we have this black tube, which is basically just a straw cut into a small piece. Okay, so once we have all of our materials here, we're going to go ahead and also you're going to need pom-poms just for decoration, googly eyes, also craft stems, and lastly some tape like this, scissors, and a glue stick. So just to give you like a speed up of how the project turns out, so this is our last final product. We added pom-poms, craft stems, and you can see all these different electronics that I'll be explaining later on today into detail. And basically Shybot is a self-moving robot. You know, you're creating all of this on your own. And it moves. As you can see here, also we have a photocell, and I'll explain what that is later on in a bit, and how this is incorporated into our project. So to start off first, I'll just give you a brief history lesson on the breadboard. So the term breadboard comes from a literal piece of wood that was used to cut bread way back in the days. And you can see here up on the screen, this was a very first prototype of how the breadboard was designed or constructed by engineers and scientists back in the days. So as you can see, these all complex mechanisms out in the open. However, fast forwarding back into current times, as you can see on the right side is a white plastic breadboard. So that's a more it's less sophisticated and more safer rather than the ones on the left, sorry. So now this is what we call a breadboard, and people build electronic circuits on it. It's a typical circuit as seen as in the picture that I showed you, and like I said, with years of evolution comes design changes. So now, thanks to the invention by Ronald Portugal, the breadboard we know comes in a smaller, more portable white plastic and pluggable design. So this is used by engineers and scientists to prototype simple projects. It's very, very low cost effective. So if we're hitting the prototype stage during designing and experimenting, this is a great way to save money also, and yeah, before moving on into like the final design. And then once we have this out of the way, I'm going to explain the transistor. So here it is. You can see it's a very, very tiny electronic device. So this is actually called a Darlington transistor, which is named after its inventor, Sidney Darlington, which is a special arrangement of 2 standard PNP or PNP bipolar junction transistors, but connected together. So the emitter of one transistor is connected to the base to produce a more sensitive transistor, which basically amplifies power or switching when required. So this basically amplifies more energy and power into the electronics. And lastly, a new concept that hopefully you learned today is called is called a photocell. So this tiny thing here is called a photocell. And this basically, whenever it sheds light on it, it'll activate. However, if I cover with my finger, it won't work right now. But later on, after we finish building our Shybot, you'll see how when there's no light shed on it, it will completely stop. So this acts as a kind of like a switch in a way, kind of like when you use to power your car, stuff like that, like a switch. Which is a circuit that we used last week in our bot, which was a simple circuit. So now today we're going a little more advanced. We're creating a more complex circuit using all of these wonderful electronic devices. So we got this out of the way. Let's move on to creating our Shybot. So first, I'm gonna put these to the side because you won't need these at the moment. So we just move these to the side, and so we're gonna take our paper plate here. So you can feel free to use any side. There's the front here and the back. What we're gonna do right now is we're gonna take our offset motor and just using our wires here, we're gonna put one wire through this tiny hole that we see here at the side. So you can see that. We're gonna put, doesn't really matter which color you put first as long as you put one through. So here's what I'm gonna do. I'm gonna show you here. I put it through and then I'm going to gently twist it. Just like that, so it's secure. And then we're gonna do a second reiteration with our second wire. We're gonna put it through the other side of the motor. So just like this, so we're gonna put it through and a twist. And remember, like I said, if you don't have wire, anything that's like a paper clip, yes, it works as well too. So now here I have two wires that have been put through my offset motor. So now we're going to just do a wiggle test to make sure it doesn't fall, to make sure it's secure, so we're good on that. Alright, so once we have this, we're going to move on onto our paper plate. So we're going to gently just puncture a hole through. It can be generally in the center where you want to put your motor through. So, as you can see here, I'm just going to just puncture a small hole. And be careful with the little ones because this is pretty tricky to put through. So just like that. So now if we flip it on the other side, you're going to see the motor, the tip of the motor just hanging out there. And now we have here. So now we're going to grab our tape and secure the sides of the motor so it doesn't move. So here I'm going to grab some tape. Right. This is masking tape. You feel free to use, this is duct tape. So feel free to use masking tape. So I'm going to grab my scissors and just cut. And to save tape, I'm also going to cut here horizontally. Like this. And rip it apart. So now we're going to attach a few, like centimeters below the motor on each side. Like this. And then on the other side, we're going to do the second reiteration and just go like that. Make sure your tape isn't covering the sides here at the bottom because that's where we're going to use to make our robot move. So now we're going to place it through the same hole we punctured earlier, just like this. And you can see here, now just with your fingertips, try to mold the shape of the motor into the plate. So just like that, so it's secure. And then now just make sure you flatten out the sides. And so so we should be good to go. Right, let me just show you the flip side of it. Now you see that. It's staying secure, so now it's not moving for anything. Okay, so once we have this, we're gonna go ahead and now program our breadboard. So remember, our breadboard is used for prototyping, and what we're gonna use with this breadboard is our transistor and our photocell. So if we can pull up here on the screen the diagram we're gonna be using to program our breadboard. It should be coming up shortly. Okay, so here actually I have a copy of the diagram that we're going to be using. So if we closely look at our breadboard here, we're going to see some numbers from labeled 1, 2, and 3. We're going to follow this exact diagram here, and just pretend you have these imaginary numbers on the side, A through E. So we have A is right here, B, C, D, and E. And also remember, the sides here are 0. You can't see it though. It's not labeled. It's 0. Column 1, column 2, column 3, and then column 4 last. We have a comment, which is, good morning everyone, thank you for watching, tuning in. Never understanding the power of googly eyes. I do enjoy googly eyes. Evelyn is great at explaining what she is doing to us. Can you use a glass plate instead? Using a glass plate, I would not recommend to do that. It is very risky because this robot is going to be moving around in very random places. So I would say using a glass plate would not be helpful, and also you would have to really be careful not to crack the glass because you have to puncture a hole through the other side of the plate. So glass plate wouldn't really recommend. Just something that's like cardboard-like and very like flexible. That should be helpful to you. So back to the breadboard. We're gonna program our breadboard, and you can see here I have a key that stands for M is for motor, DT is for our Darlington transistor, which is this fellow right here. And then PC basically stands for our photocell, this right here, and our battery pack, which is this. And so now we're going to start off going by A with our motor. So remember, have the numbers facing you towards you. And so we're going to begin with A is our red motor wire. So I can just put this here. Alright, so the first one on our board would be A and our motor. So this is this one. We're going to bend it. And to make sure we put it through 0 and A, as we have here on the diagram. So M would be for motor. So we're taking our red wire and then putting it through that hole. So A0. So now we have our imaginary letter A and the column 0 right here. Now moving on to the next row is A and 3. So we're going to take our black wire and we're going to insert it inside the number 3. So number 3 is right here. If I go straight up, I have this right here. Also, if you guys have any comments or just any questions, feel free to write them down and I will make sure to answer them before we end the session. Right there. Okay, so then we're gonna go on to our next row, which is B, and that is our Darlington transistor, which is this guy right here. And make sure you want to have this metal side facing you. So we're gonna go B, and it's occupying numbers 2, 3, and 4. So we have our imaginary B here, and then we're going to use rows 2, 3, and 4. So if I can insert it here, and make sure you gently insert, because you don't want to bend your wires. The next is our photocell. Also, you want to be very, very careful with this because the wires on here are very, very bendy, and they can really bend that easily. So our next row is C, and it's occupying number 0 through 0 and 2. Notice there's a blank spot. There's nothing going inside this hole, only pertaining to 0 and 2. So we skip down. I am going to do 0 and 2 right there. You can notice. Right there. Right. Oh, it's making a little. Wow, there we go. Let's see. Alright, there we go. So our next one would be our row E, which is our battery. So remember our battery pack. Now would be a good time to insert these batteries. This side. Also remember there's a positive and negative side labeled on each side of the battery. So you just want to follow the exact same pattern here. So you can gently see the plus and then the minus. So we're going to do the opposite of that. Right, so now we have the minus and the plus. And now we're going to take our black wire and put it with E and 0. Then the next one would be battery, row 4. Column 4, sorry. So now you can start to hear that sound, and if I flip it over gently, you're going to be able to see how the motor is moving. You can barely see it, but you can hear the sound. So now that we have this working and we know for sure, we're just going to unplug it for now. But there is actually a switch that's built in with this breadboard that will not require you to unplug. But I just want to do this step right now because I want to tape down the breadboard and the battery pack. So I'm going to grab some tape. We're going to cut a small piece of it. We're going to fold it just like this. And we're going to put it behind our battery pack first. And then we're going to place it near our motor. So about that distance is great. We're just going to press it down to make sure it's really secure. And then we're going to tape down our breadboard. So again, I'm going to grab a piece of tape. Like this. Cut it. And then we're going to tape down the breadboard. So again, like do a little loop like that and press it down. And I'll move these wires here. Oh, there we go. And we're gonna position it right there. Okay. And remember, we're going to plug this back in, which belongs to the row 0 and column E. So now we're going to place this back. Put it in here. And now you should hear your motor working. So if I can just display it, it should start moving. Right? There we go. However, now since it's moving, this photocell, remember, it will act as a switch because it's requiring a sunlight or light to power this on. However, there's a switch also built in with this. So remember the black tube that I mentioned earlier? This will help act as a switch, because if you place it over the photocell, it should stop the motor from moving. So you can hear that it stopped from moving. Oh, never mind. It takes a few tries to get this to stop moving. You can hardly hear the motor moving, but it's there. There we go. Alright, and remember, you can also put this in direct sunlight, take it outside. If you can use your phone to add light to it. Also, maybe a dark place would also help. And just like that. Would anybody like to troubleshoot this, since it's not working right now? You can, like, even if I put this black tube over here, what would be some other factors that are holding me back from the photocell not working? Does anybody have any suggestions, any comments of why this is happening? Is it because of the sunlight, there's too much light in here, or the power? Let's see, let's read some of your questions. Or do you think it would be better if it's working outside, more of an indoors, enclosed, under very little light? What are some of your suggestions? Let's see here. Okay. Thanks. Okay. So, meanwhile, the comments are loading in, we're gonna go ahead and decorate our Shybot. So remember, we have a pair of scissors, and if you're a kid, remember adult supervision when handling these. So I'm gonna just go ahead and cut a few slits open here on this side, just like that. Just something simple. I'm gonna use this as my teeth for my Shybot, and just kind of bend it down like this. Right. I am going to grab my glue stick and my googly eyes, and I'm going to just add some glue to the back of this and place it on here. Like right there. Make sure it sticks. We're also going to okay, let me read some of your comments. Cool. Do you need a flashlight? Can actually, yes, you can create your own battery pack using the Shybot. Remember, last week we used paper clips, a rubber band, and one double a battery. So you can also create your battery pack out of materials that you have at home. This is also not required, but however, if you purchase our kits, we will make sure to include all of the materials you see here. So now we have our googly eyes. We're going to add some pom-poms. And also, maybe having a flashlight and putting light directly to the photocell would also make it work. So now we're going to put pom-pom there. We're going to add some glue. Oops. Let's see where the glue is at. Maybe that's up here. Let's see what other comments have you. batteries. That's a good idea. Maybe the batteries are out of date or expired. But let's try it one more time. Let me just finish decorating. And we should be good to go. Let's just put it here. And we're gonna have just one last pom-pom. Right, so we have our googly eyes. Let's make sure they're secure. And also feel free to create some drawings around here, like squiggly lines, some polka dots, circles, anything you feel free to go about. Whatever your creative mind desires. So now we're just gonna go ahead and try it out one more time. So this would go here. And it's should be working. Let me just move everything out of the way. We know here at 2-Bit Circus we're all about upcycling our materials. What other materials would you guys use that come up to mind while creating this project? Other than using a paper plate. For example, cardboard is a good one. There's pretty sure an abundance amount of cardboard at each house. Like cereal boxes as well work very well, and you can cut out like squares and triangles. Use different types of materials of cardboard. Alright, so there we have it. And let's try it on with our photocell. Again, if we have our photocell, it's not really working because as soon as we attach or insert this black tube, it should kind of slow down or turn off. But we can see it's not. In this case, we can tell that it's the light in here. It's very bright in here, so that's why it's not going through or sending the signal of slowing down. But that's okay. Once you try it at home, make sure to upload photos to our Instagram. Our hashtag is 2-Bit Circus Foundation. And you can also find more projects on our website. So this is our Shybot here. Are there any questions or comments? And if you guys have created this project at home, feel free to go out of your creative ways and use our hashtag 2bitcircusorg. We are excited to see your photos and interested in knowing what you guys created at home. I'm gonna just check the comments one more time. Shybot is trying to escape. What does the back of the plate? The back of the plate looks like this. So if I can just gently show you, it's basically just a motor spinning around in circles. So that's the back of the plate. All of the electronics are facing up. So there we have it. We have our Shybot. Are there any questions? What does the back of the plate look like? No problem. If you guys have any more questions, feel free to comment down below. Also check out our kits pretty soon. Like last week we demonstrated Arbot. That would also be included as a kit. Shybot is also a really popular one. And there's so much electronics going into this. Like mentioned earlier, Arbot was more like a simple circuit, while Shybot is more like an advanced and more complicated, complex circuit. Because you're using all these different electronics, and I'm pretty sure we hardly ever are aware of this. What about... Sorry, I can't really see this comment. What about... Okay, yes. So we're good. Okay, so now we're gonna wrap this up and we're gonna continue with another segment from Mario. Would we like to just switch this off? And thank you guys for tuning in.
Hi, my name is Mario, and today we're going to go over Spheros. So this is basically a programmable, you could say, like a breadboard, but basically this is the final product that is made at the end. So this breadboard, well, it used to be, so engineers use breadboards to create prototypes. It's a cheaper, more affordable way, and the final product actually creates a circuit. So this circuit has a variety of sensors and Bluetooth modules, so it can communicate via Bluetooth to your smartphone devices. And you can actually get these Spheros at local stores. You can buy them for relatively, like, for maybe $50 around there. But these are also programmable, so you could spend time at home and you could program them, and it's quite easy for kids to pick up and learn. So here you can see that it's basically block coding. So block coding means that it's easier for kids to program, so they can just plug like these simple blocks into the code. So it's very easy for them to program. And right now, since the space is quite small, we can do a simple program for the Sphero. So right here, the program is said to loop 2 times. So what that means, looping, means that it's going to go in a circle. So it's basically going to repeat the code I wrote here 2 times. So it's going to go from the main LED that's pink, and it's going to roll 270 degrees for 1 second, and then fade from these colors for about a second and so, and then roll back to 90 degrees. So let's give that a try and see what that does. So as you can see right there, that this program is basically programming the Sphero to move in that direction. And you could also, when it rolls in that direction, you could also increase speed, which direction you want it to go in. So right now it's being told to roll 270 degrees and rotate at speed 45 for 1 second. So let's give that a shot and see what it does. So it rolled off to the side. So you can do a huge variety of things with these type of robots. You can make it go through obstacles, or let's see. So there's different programs here. There's movements, as you guys can see here. There's movements. You can tell it to stop. You can tell it to go a certain direction for a certain amount of speed. And then you're also able to control lighting on it. So if you were to click on the color, you can dim down the lights and make them brighter or darker, depending of your liking. So let's see. We could lower these lights as well, and lower these as well. Good. So here they also have the light settings. You could do fading. You can make it strobe, and you can make the LED go back to like dark and light. It could also do sounds, but the sound will be coming from your device. So we can go ahead and try out a sound and see what that would sound like on the robot. So we can move all the extra lights off, and we can try playing the sound. So in order to play sound, your device has to have volume on, because it's not going to project the sound from the device. So let's see. So that was the sound that this created. So basically what it's doing, it's creating a random noise that it was programmed to. So it says play random sound and wait. So it's going to keep playing random sounds until it's told to do something else. So if you're trying to go after a specific sound, you're able to choose what kind of sound you want it to do. So there's different kind of noises, ambience, so city. So there's different noises you can choose as well. We can go for the next section. There's controls, which you can see there's a delay. So that's basically telling the Sphero to wait a certain amount of time if you want it to do another task. So let's see. Let's try delay. So we can tell it to move or roll, let's see, roll 90 degrees, and we can make it move forward at speed 80 for about 0.5 seconds, and let's see, we'll make it roll again, but we'll add a delay. So the delay is going to make it wait until the time has passed. So we're going to make it wait for 1 second, and then it's going to roll again for at 270 degrees and roll at, let's see, at 37 speed for 0.5 seconds. So let's see where that takes us. So now we could start the program and see where the Sphero goes. Alright. So basically, since the table is too small, we can't really give the Sphero a large complex code because it'll end up rolling off the table and possibly breaking. So it's best to program these on the floor and, just to make sure the Sphero doesn't break. So let's see. So we could make it, there's different types of code here. Loop until true. So basically what this means is until, oh, is there any comments? Oh, where are the comments at? Oh, okay. What about switching? Do you guys have any suggestions for programming this robot? I mean, the Sphero, so we can try that out. And we have a variety of codes, true and false statements, what if, exit program. They also have math involved in here. Let's see, they have math. They also have sensors. You can access sensors. You can get one of these from your local store, Target, Best Buy. Any electronic stores would have these devices that are programmable. And they're pretty neat and they're quite entertaining for the kids. Let's see. Right here we can mess with the gyro. Let's see. Super cool things. We also have a program that offers using these for Spheros, so we can show kids how to program them. And there's a maze that we have, and the kids have to program the robot in order to get through the maze for the program that we do here at 2-Bit Circus. So, and it's also, if programming's too hard, the kids can always try to control it manually. There is a program here that lets you program it manually, or drive it manually, per se. Let's see, and that is right here. So basically, right here you can choose the color, and you could also dim the lights if the lights are too strong. Right here, you could control the direction you want your Sphero to go. And then you could also control the angle you want it to go to. So this is basically pointing the degree you want it to go. So you want it to go forward, which is 0 degrees. This is 90 degrees, 180, and 270, and 360. And right here, you're able to adjust speed if it's moving too quickly. So it'll move slow. Oops. So you can make it move slower if it's moving too quick. So right now, since speed is set to 0, it'll just rotate and not go anywhere. Lift it. This one. So we can increase the speed just a little bit and it could roll around at a low speed. Since we have like a small little area for it, You can go back to coding. You could try. Let's see. So this robot does communicate through Bluetooth. There's other robots that can communicate through Wi-Fi, and you could use those in further range. This one's more close range, so you probably have to be within, I want to say 10 feet of it. But once it's programmed, it can go further. But when you're trying to control it manually, you'll need to keep a distance within it so you can continuously communicate and tell it what to do. So let's see. Let's get rid of these extra code here. So the app I'm currently using is Sphero's Education. So this allows you to program it, and they also have tutorials on how to program if you're interested in trying to program it yourselves or your kids. It also guides you on how to program it, and you could have a variety of programs in this app. And they also have tutorials on how-tos. And there's different kinds of Spheros. If you're trying to program different ones, they have a variety of different kinds. Let's see. That's manual. So let's see. We can try programming it to do something else. So we can go from, actually, we can make the lights strobe for, let's see, we'll make it strobe for a second, and we'll make the color less brighter. So in this program, it's going to tell it to strobe for 1 second. I think, let's see, let's go for longer, 5 seconds. It's not strobing. Oh, we're supposed to set time and how many times you want it to strobe. So we'll make it strobe for 2 seconds and 5 times. So every 2 seconds it'll strobe 5 times. We could make it strobe faster if we increase the number, so we can make it strobe 100 times. Let's see. It's not strobing as fast, so let's see, we lower the time. So, let's see. Let's get rid of the extra code that might be throwing it off some. So usually to get rid of code, you just have to drag it to the bottom to the red trash can. So you just drag it down and it'll delete the code. Or you could hold it and you just manually select delete. Let's see. Let's see what we can try to make it do. We can try to keep it within this area, so I'll try to program it to stay within the area. So first we'll need it to roll, let's say, straight at 0 degrees, and let's see, and we'll have speed at, let's see, I'm trying to increase speed to 23, and I'll go straight for 0.5 seconds, and let's see where that goes. So that went straight, so we can keep it to go straight. We're going to aim it straight. So let's see where that goes. Right off the edge. So then we'll tell it to wait. So we're going to give it a delay of 1 second. Let's see, 1 second. And we'll tell it to roll in another direction. So let's see. We'll tell it here to roll 90 degrees. And then speed at, let's see, let's increase the speed at 26 for 0.5 seconds. So let's see where that would go. Hopefully it stays within the block. Alright. So it looks like it's going in this direction. So we want it to go in this direction. So we'll just change the degrees to 180 or 270. And let's see where that goes. So it should rotate. Let's see, let's reset it. Alright. So usually when you're reprogramming it, you want to make sure you set your robot to the 0 position. So you grab it and you set it to 0 as such. And then since we want it to go this way, we want it to go that way. So let's see. Any comments? Alright. So let's see what we'll do with that program. It's not going anywhere. Okay. Reset. Alright, so let's try that program again. So it's staying on the edge of the board, so we're going the right way. We can tell it to go in another direction. Let's see, momentums, roll. We'll want it to go back to 0. Oop. Let's see. And we'll decrease the speed to 21. We're making it go in that direction for 0.5. And let's see, let's start the program and see what it does. Alright, so that went in the wrong direction. So we're going to have to change the roll degree angle to 180 so it comes back in our direction. So we click the check, so it's now roll 180 at 21 speed for 0.5 seconds. Let's see where that heads. Alright, so now it came back to where it started. Now let's see if we can make it go for a longer duration there. So we'll hit the program stop. So it's going to be at its starting point again and roll for possibly, let's see, 0.8. So that means 0.8 of a second. Let's give that a shot and see what happens. Whoops. Came off the table. Let's see. Alright. So let's reset this to 0. How do we put that to 0? Okay. Alright, so it stayed on the table. We could put it in another direction. We can continue to add more code. Does anybody have any suggestions on what should the robot do? Let's see. Sarks. It's cool. Sphero's also trying. You should probably watch it. Let's see. Let's see. Let's see what else we can add to this. So we'll make it start at 0 again, and let's see if the code will work. Alright, so hopefully we can keep it on the table and try to further expand the code. Let's see. So we can make it fade colors. So it's basically going to let us know that it's going to change directions. So as you guys can see, so I added fade colors. So it's basically going to let me know when it's going to turn. So we'll let it fade colors for 1 second. And then when it's turning in another direction, let's see, let's add that up here. We'll make it fade another color. Blue when it's turning, and red. So now it should tell us when it's going to turn. So it's going to tell us by changing color. Oops. So it's trying to head in the opposite direction, so probably have to set the Sphero to 0 once again. Let's see. Place Sphero on ground. Okay. So now we can try the code again. So as you can see, it was changing color and it was letting us know what direction it was going to go towards. So let's see. You have to set it back to 0. So basically when you're setting it back to 0, this blue light has to be pointing away from you. So basically that means it's going to go that way when it's at 0 degrees. Let's see. Let's try it again. So now it's changing. It's going to go the other way. It's going to come back. So now let's reset it again and let's see if it works. So now it's going to go for 0.5 seconds, and we're going to see if we can complete the whole board. So when it turns, we'll make it go for about a second or so. Let's see. Second, 25. Okay, so let's give it a shot and see where it goes. So now it's going to turn. So it's almost all the way there. We can try, let's see, I'm going to try it again. And I'm going to set it back to 0. So that's at 0. And we'll make it go for about 2 seconds. So you can complete the whole little wood sheet. So 2 seconds. And let's see. Alright, so let's see how that goes, and we're going to start the program. That was 2 seconds was too long, so we're probably going to have to cut down the time to 0.75 maybe. So we're going to go 1.75, and then we'll hit the check mark and reset the Sphero to 0. Alright, so now let's give it another shot and see if it completes the wooden table. Alright, so it completed it. So now we want to do a full circle, see if we can complete it. And we're going to add another program underneath it. So we're going to tell it to delay for a second when it turns. So we got another delay. And we're going to tell it to, let's see, roll at 270 degrees. So basically it's telling it to point this way and come in this direction. Alright, so put it up, okay. Speed at 42 for 0.75 seconds, and let's see, so now we're going to reset it. So now it's already set back to 0, which is good. So now let's see if it will complete the whole circle here. So now it's going to rotate, go in this direction, and it completed the circle. So we can make it do the circle 2 times, so we can go into control, and we'll tell it to loop all of this code for, let's see, we'll make it complete it 2 times. So now we're just going to set the Sphero back to 0. And let's see, make sure it's pointing in the direction. Alright, so now we can check it out and see if it'll do 2 complete circles around the wooden block. Alright, so it should complete it again. Oh, looked like it might have got disoriented and incompleted. But everything is trial and test, so you have to keep messing with it to figure out the way it truly works, and since every material is different, so it'll react differently to all the materials. Let's see, so alright, so basically today we learned, well, you guys learned from Evelyn how to use a breadboard in our Shybot, and This device is great for prototyping, and when you're prototyping, you end up with a result of something like this, basically a circuit board. As you can see, like this is a much more finer touch than the breadboard itself. And with our example of Spheros, we can see how engineers solder wires and to make them into solid connections. So you can see here that there's like small soldering and small chips inside of it and resistors. So basically this is the final product when it goes from breadboarding to circuit boards. So basically these are all inside our computers, and basically all the electronics we have, they all consist of using circuit boards. And let's see how to make program to make, and all these basically breadboarding, this is how we start from making our robots. And remember our hashtag remember our hashtag 2-bit circus. If you would like to try it out today, our project kits will be available soon. And thank you for watching, and hopefully we'll see you tomorrow. Thank you. Do we? All right. Bye. How do we end it?